On this Honda Civic 1.8 gas application, identified as 2015 Honda Civic Sedan L4-1, 8LR18Z1, P1659 points to an ETCS control relay OFF malfunction. In plain language, the PCM may not be seeing the electronic throttle control relay circuit behave the way it expects. The vehicle may have throttle-related warning behavior or reduced throttle response, depending on when the fault shows up. The broad fault areas can include the ETCS control relay, its fuse and power feeds, relay control wiring, the fuse and relay box connections, or a possible PCM software or PCM issue. Before diving in, start with the basic system checks and make sure any obvious connection or terminal problems are handled first. Start by turning the ignition on, then clear the code with the ETCS. After that, check for pending or confirmed codes and see whether P1659 comes right back. If it does, the failure is duplicated and you can move into the circuit checks. If it does not come back, treat it as intermittent for now. The system is okay at this time, so focus on poor connections or loose terminals at the ETCS control relay and the PCM. If captured operating data is available for this code, try to reproduce the same conditions instead of guessing. With the ignition OFF, check fuse no. A22 rated at 15A in the underhood fuse and relay box. If that fuse is okay, continue with the relay test path. If the fuse is not okay, skip ahead to the short-to-ground checks for the relay output and power feed circuits. For the normal fuse OK path, remove the ETCS control relay from the under-dash fuse and relay box and test the relay. If the relay fails the test, replace the ETCS control relay. If the relay tests OK, keep going into the feed checks. With the ETCS control relay still disconnected and the ignition on, check the Phi main RLY-OUT circuit at ETCS control relay for P socket no. 3 to body ground. You are looking for battery voltage. If battery voltage is present, move on to the plus B dBW feed. If battery voltage is not present, turn the ignition OFF, jump the SCS line with the HDS, disconnect PCM connector A, 51P, and under-dash fuse and relay box connector C, 38P. Then check continuity on the Phi main RLY-OUT circuit between PCM connector and no. 9. The ORN wire and under-dash fuse and relay box connector C no. 9. Also ORN. If continuity is present, that wire checks OK, and the next supported repair is the under-dash fuse and relay box. If continuity is not present, repair the open in the Phi main RLY-OUT wire between PCM A9 and the ETCS control relay. Next, with the ignition on and the relay disconnected, check the plus B dBW circuit at ETCS control relay for P socket no. 1 to body ground for battery voltage. If battery voltage is missing, turn the ignition OFF, disconnect under-dash fuse and relay box connector D, 32P, and check the plus B dBW circuit at connector D no. 12. The YEL wire to body ground. If battery voltage is present there, the plus B dBW wire checks OK, and the next supported repair is the under-dash fuse and relay box. If battery voltage is not present, repair the open in the plus B dBW wire between the no. A22, 15 a fuse and the under-dash fuse and relay box. If battery voltage was present at the relay socket, turn the ignition OFF, jump the SCS line with the HDS, disconnect PCM connector C, 51P, and check continuity on the VBDBW and DBW RLY-OUT circuit between PCM connector C no. 1. The WHT/GRN wire and ETCS control relay for P socket no. 2. If continuity is not present, repair the open between PCM C1 and the ETCS control relay. If continuity is present, disconnect PCM connector A, 51P, and check the DBW RLY-CL circuit between PCM connector and no. 50. The YEL wire and ETCS control relay for P socket no. 4. If that circuit is open, repair the open between PCM A50 and the ETCS control relay. If that circuit has continuity, the wiring checks OK. Update the PCM if it does not have the latest software, or substitute a known good PCM. If P1659 goes away after an update, troubleshooting is complete. If it goes away with the known good PCM installed, replace the original PCM. If fuse no, A22 was not OK, stay on the short check path. There is one location detail to be careful with here. Confirm you are working at the actual ETCS control relay cavity before testing, and do not guess if the vehicle layout does not match what you expect. With the ignition OFF, the ETCS control relay disconnected, the SCS line jumped with the HDS, and PCM connector C51P disconnected. Check continuity on the VBDBW circuit between PCM connector C no. 1. The WHT/GRN wire and body ground. If there is continuity, repair the short in the VBDBW and DBW-RLY-OUT wire between PCM-C1 and the ETCS control relay. If there is no continuity, that circuit checks OK. Next, with the relay still disconnected and PCM connector C still disconnected, check the plus B DBW circuit between ETCS control relay 4P socket no. 1 and body ground. If there is no continuity, update the PCM if needed, or substitute a known good PCM. If P1659 goes away after an update, troubleshooting is complete. If it goes away with the known good PCM installed, replace the original PCM. If there is continuity on the plus B DBW circuit, disconnect under-dash fuse and relay box connector D32P and check continuity between connector D no. 12, the YEL wire and body ground. If continuity remains, repair the short in the plus B DBW wire between the no. A22, 15 a fuse and the under-dash fuse and relay box. If continuity is gone, the plus B DBW wire checks OK, and the supported repair is the under-dash fuse and relay box. After the supported repair, verify the repair and confirm P1659 stays gone. Keep the verification separate from the circuit testing. Do not call it fixed just because one measurement looks good. The takeaway is simple. Prove the code first, split the path by the fuse result, then isolate relay, power feed, control wiring, fuse and relay box, and PCM only in that order. For more diagnostic training, visit stepdiagnostics.com.